So here we're going to be looking at equations. So far we've just been looking at algebraic expressions. What's changing now is that we have this equal sign, which basically sets a relationship, meaning there's some value for x in these cases that balances the equation. Now in solving equations, we just need to keep in mind that whatever we do to one side, we have to do to the other. So we need to keep balance as we solve through. What's really nice about solving equations is that we can always check our answer. So we can always check and make sure that we've done it correctly. So here are kind of the 4 cases for solving equations in just a single step. So a case where we have addition, where we have subtraction, if something's multiplying, if something's dividing. So the idea is that we want to get x all alone on one side of the equation so that we just have x equals and then a single number. So for our first case here, I have a 2 adding with x, and what I want to basically do is create a 0 there where we have this plus 2. So to undo that addition, what I need to do is subtract 2 away so that I have 2 minus 2, which turns into a 0. But whatever I do to one side, I have to do to the other side too. So what I like to do is wherever that equals sign started, just kind of keep it in place. So you have this location of left versus right. So on the left side of the equation, now we would just have x, since the 2 minus 2 canceled out, and then 6 minus 2 is 4. Now checking our answer, be sure to separate this from the work so it doesn't look like a continuation, but this is where we would substitute in. So I have x plus 2, and I want to see, does this equal 6? So what I want to do is plug in positive 4. So we have 4 plus 2, which is 6. So since that balances out, we know we found the correct answer. Okay, here we have a negative 4 plus x, or you could think of this as x minus 4 equals 5. That would be the same thing. So since we have this negative value, to make it a 0, I need the positive version of it. So I need to go plus 4 so that I have essentially 4 minus 4. And whatever I do to one side, I have to do to the other. So we'd have x equals 5 plus 4, which is 9. And then we could check our answer by going ahead and doing negative 4 plus 9. And is that equal to 5? And it sure is. So we know we got it right. Okay, if we have something multiplying with x, what I essentially want, and if I go back here, it's like I have a positive 1x. I want this numerical coefficient of 1. So to do that, to undo multiplication, I'm going to use division. So I have this 3 multiplying with x. So to get a 1 there, I need to divide by 3. So that 3 divided by 3 is 1. So then I really have a 1 times x. But whatever I do to one side, I have to do to the other. So 27 divided by 3 is 9. And then we could check it by plugging in and making sure that 3 times 9, and does that equal 27? Which it sure does. So it balances and all works out. So x equals 9 would be our solution. Similarly, if we have something dividing away, it's kind of like I'm working in reverse here. Like imagine I started with that x over 3. Then what I would need is that 3 multiplying with x. Same idea here. I have my denominator already. What I need is something multiplying in my numerator. So I need 4 times that x over 4. So I'm just using that denominator so that they cancel out. And then I would just multiply by 4 on the right hand side as well. So on the left hand side, so it would cancel out to a 1. And then 3 times 4, which is 12. And then we could check it by plugging in 12 divided by 4. And is that equal to 3? Which it is. So we have balance and we have that value. So these are the cases for how we can kind of isolate x in just a single step.